For the first half of this unit, we've been reviewing things that were essentially all review of grade 10, SOHCAHTOA, sine law, cosine law. Now we start introducing some of the new stuff that is for grade 11, including the special triangles. So we've been practicing these every day for the last couple of weeks. So we should have these memorized by now. This is the half of the equilateral where it's 1, 2, root 3. This is the small triangle is 30, and that's 60, the small angle, excuse me. It's pretty hard to read, but maybe I'll do that a little bigger down here. So 1, 2, root 3, there's the 30, there's the 60. And the other one is the equilateral triangle, 1, 1, root 2. And it's 45 and 45. Again, I'll make it a little bigger over here. 1, 1, root 2, and 45. We really don't have to label both 45s, but nonetheless. All right, so in each of these then, we're just using the special triangles to get the answer. So if I'm doing the sine of 45, I got to look at this triangle. Sine is opposite over hypotenuse, and so that is 1 over root 2. Cos is adjacent over hypotenuse, but it's the same. Since they're both 1, it's going to be also 1 over root 2. Minus the tan of 60, so now we're looking at 60-degree angle. Tan is opposite over adjacent, so that's root 3 over 1. And sine of 30, now we're switching our attention to the 30, and that means that this becomes the opposite 1 over hypotenuse, which is 2, so 1 over 2. And now it's a matter of just simplifying this expression. On the bottom, I've got root 2 times root 2. Well, that equals root 4, which of course is just 1/2. On the top, it's 1 times 1. You might not write the root 4 part. You might go straight from here to there. On the second part of here, we've got root 3 times 1, so that's root 3 on the top, and 1 times 2 on the bottom. So that's root 3 over 2. And then we just got to add these fractions, or sorry, subtract these fractions. Fortunately, they're both have a common denominator already, so then it's just 1 minus root 3. No need to go to a decimal here. It says the exact value, which is the whole reason why we're doing this. We're finding the precise answer, not some decimal approximation. In the second one then, we have the sine of 180. So these are ones that we just have to know as well, but we might use our calculator to help us with that. Sine of 180, if we punch that in our calculator, is 0. 99 times the cos of 90, which is 0 as well. And so this really isn't very exciting. We just get 0 as our answer. So next we looked at the primary chain ratios of an angle whose terminal arm passes through the point 4, -2. So we discovered a general case for these. Sine theta was y over r, cos theta was x over r, and tan theta was y over x. If you have those memorized, then the question's really easy. If not, don't be afraid to just draw a quick little picture to help you visualize what's going on. So if I'm going to draw this, I'm going to draw the point 4, 2. So 1, 2, 3, 4. 4, -2, excuse me, goes right there. So there is our point. It goes through 4, -2. And we can build the theta as this guy here, theta. Build this right triangle, and we got 4, -2. Now we're just using SOHCAHTOA to find the sine of each of these. So the sine of theta is opposite over hypotenuse. Oh, I need to figure out the hypotenuse though, don't I? So that's my missing side. This is the r part, remember? The r standing for the radius. So you can do r squared equals 4 squared plus negative 2 squared. 4 squared is 16. Negative 2 squared is 4. So we get 20, but we have to take the square root of 20. Now, the square root of 20 is something that you can reduce. Remember, from last unit, we can look at, or maybe 2 units ago maybe, we know that this can be 4 times 5, and so this can be 2 root 5. So we'll use that number instead, or root 20, we'll use that instead of the decimal. So back to what I was doing, sine is opposite over hypotenuse, so that's going to be negative 2 over 2 root 20, and that will reduce to negative 1 and 1, and that would be negative 1 over root 20. Cos theta is going to be adjacent over hypotenuse. So the adjacent side to theta is that guy, and the hypotenuse. So that's 4 over 2 root 20. Oh, not root 20, excuse me. 2 root 5. I'm sure you're probably screaming at the video. All right, so this is 2 root 5. I reduced the root 20. So that's going to reduce there, and this is just going to be negative 1 over root 5. This one is 4 over 2 root 5. And these can reduce, divide the top and the bottom by 2. And we get 2 over root 5. And finally, tan theta. Again, looking at my picture, if that's theta, and opposite over hypotenuse is negative 2 over 4, and that just reduces to negative 1/2. So this one ended up being just slightly harder because we ended up with this root 20, which can be reduced. I think the one we did in class was like root, 13, and that one we can't reduce. So we would just leave it as that. All right. By the way, you'll notice that it turns out that the sine ratio was negative, and that's because we're in this quadrant. So right after talking about this, we use this fact to figure out the cast rule. Cosine's positive in that quadrant, so you'll notice that sine is negative, cos is positive, and tan is negative. And those are all the things we discovered after this lesson about the cast rule. I'll just delete that for our notes though. Okay. And here's the valuable part of that, of understanding the cast rule and related to acute angles. So in each of these, it's the sine of 150. So we draw our picture. I asked ourselves, where is 150, which quadrant? And it's in the second quadrant. You guys are getting very good at that. So we ask, whether is sine, is our answer going to be positive or negative? And since it's in the S quadrant, or the second quadrant, the sine quadrant, sine is positive. So we're going to write down plus sine, and then we use the related to acute angle. Since it goes 150 all the way over here, a full rotation, well, not a full rotation, but all the way over here would be 180. So 180 minus 150 is 30. So we have the sine of 30 is what we're figuring out. Remember that the plus comes from the cast rule, and the 30 is the related to acute angle. So the reason we did this is because 150, we don't have a special triangle for 150, but we do know it's the same as the positive answer for sine 30. And sine 30, we do have a special triangle. So I'll write it out again. Up here, 1, 2, root 3. There's the 30 up there. And so if I'm doing the sine, it's opposite over hypotenuse. So it's 1 over 2. You could put the plus if you wanted. I definitely would recommend putting the plus in the first line because that's your process. You are going through and checking to see if it's positive or negative. This one's positive, so I'm writing the plus down. You don't have to write the plus down, but we do kind of understand why we're going through it and saying, okay, I've checked it, it's positive. And then I use the related acute angle. Let's try and do 120 now for cos. Cos is also in the second quadrant. So we're doing something like that. But since it's in the second quadrant and I'm asked to find cos, only sine is positive in the second quadrant. So this time it is negative cos, and I need the related acute angle. This is 120 degrees. The whole way over is 180, so if I subtract that, that means that's 60. So now I'm dealing with cos of 60. Again, I don't have a special triangle for 120, but I do for 60. And I know it'll be the same digits, the same numbers, just it'll be the negative version of it. So since I'm doing 60, cos is adjacent over hypotenuse, which is 1/2. And so my answer is negative 1/2. Cos 60 is positive 1/2, but I'm not actually at 60. I'm in the second quadrant. That's why it's negative 1/2. And again, you could check that on your calculator. Remember, this one you're not, I mean, you can check on your calculator, so you will have access to your calculator, but I need to see both lines to see that you're understanding it. Okay? And if we end up with like something like root 3 over 2, you're not going to use the decimal one. Let's see if that pops up in C. So in C, again, I'm going to draw a picture. 315, well, that's all the way around. Not quite all the way around, but it does come all the way around to here. That's 315 degrees. A full rotation would be 360. So this one must be 360 minus 315, which is 45. So this guy is 45. Now, first, though, we of course have to figure out, is tan positive in this quadrant? Well, only cos is positive, which means this is equal to negative tan, and then we figured out already that the related acute angle is 45. I don't have that special triangle drawn. Oops. 1 root 2, there's 45. Tan is opposite over hypotenuse, so this is going to be negative 1 over 1, or just negative 1. Let's do 225 in D. So 225 is more than 180, but less than 270. There's 270, there's 180, so it's somewhere around here. It's in this quadrant. I've been asked to find the sign of it, so C-A-S-T. Well, only tan is positive in there, so this is going to be a negative sign, and then whatever its related acute angle is. Oh. I'm doing this one in blue. So the related acute angle, well, if the whole thing is 225, excuse me, this one must be 225 minus 180, because I've gone past 180. And I've gone 45 past it. So although I don't have a special triangle for 225, I know it's going to be the same as the negative answer for sine 45. And sine 45 is going to be opposite over hypotenuse, so there's my 45, opposite over hypotenuse, so that's negative 1 over root 2. And this is where I'll know whether you used your calculator or not, because your answer has to be exact. Right? Remember, up in the instructions, the answers are exact. And if you gave me a decimal, it would not be, there we go, exact. Okay, so you need to leave it as negative 1 over root 2. Now you can check, do negative 1 divided by root 2, get some decimal, and it should be the same as sine of 225. All right, and then in E and F, we have some new angles, and these ones are coterminal angles. They have coterminal angles. So that means we have to figure out where they are, or maybe take away a full rotation. So this one is negative 210. So negative means we're going to go in the opposite direction. So we're going to go counterclockwise. 210 is more than 180. So we're going to go around over to here and then stop someplace over here. That is negative 210. So a related acute angle would be, well, how would I get there straight from standard position? What if I was going this way straight? Well, that would be 360 minus 210, and that would be tan of 150. So this guy is 150. That's the coterminal angle. But you don't necessarily have to write it as a coterminal angle. You can just go off and say, you know what? I'm in the second quadrant. Tan is negative in that quadrant. So I can go straight to negative tan. And that picture, I can still figure out the related acute angle. If I went 210 degrees from here all the way to there, I went more than 180. So 210 minus 180 is 30. So this must be a 30. Or, since I did write the coterminal angle of tan, or of 150, I could say it's 150 from here to here. I need 30 more to get to 180. Regardless, it's negative because it's in the second quadrant, and the related acute angle is 30. So negative tan of 30. So we'll have to sneak up and get my 30-degree angle. So there's 30. Tan is opposite over hypotenuse. So that's 1 over root 3. But mine is going to be negative 1 over root 3. So the only difference in this is we had a coterminal angle where we had to figure out which quadrant it's in. Next, sine of 450. Well, hopefully you've noticed that 450 is more than 360 degrees. So we've gone past 360 degrees. So I wonder how far past. So there's 450. If we take away 360, then that leaves me with 90. And so what's going on here is I'm going forward one full rotation. Oh, sorry, I went backwards. Okay, here we go counterclockwise, one full rotation, and then I'm up at 90. So this is the same as the sine of 90. And it's not in either quadrant, so we can just go to our calculator here and we will get a precise number. Sine of 90 is just 1. And so in this one, we had to do the coterminal angle, but it ended up giving us something that is pretty easy to figure out. All right, and for our last questions, we are figuring out the angles, the two angles for each of these ratios. So we discovered that, hey, when we do inverse sine on our calculator will give us one answer, but it won't necessarily give us more than one answer. And we discovered that, of course, there's more than one answer in these. So in the first case here, I have sine theta equals 0.76. The key is it's a positive 0.76. So I'm going to draw my picture, and since it's positive, the CAST rule will tell me where my two answers are going to be. I have to look in the quadrants in which sine is positive. Well, all of them are positive in this quadrant, and sine is positive in this quadrant. So I end up with two possible answers from standard position. I've got this little guy, and then I've got this guy here. That's important because when I go to my calculator, you're going to push second function inverse here. So you type in 0.766 second function sine. We get an answer, and that answer is 50 if we rounded to the nearest whole degree. So that means that this guy here must be 50. And it's right. The calculator is telling me that it's 50, but it can't tell us that there's another answer. Not only is that 50, but the related acute angle over here is 50, making this entire thing 180 minus 50, and that means the other angle is 130 degrees. Again, without the picture, it makes it difficult to interpret what the calculator is trying to tell us. And the rule isn't always the same. We're not always going to subtract from 180. It depends on the picture. Okay, let's draw this next one. So this next one, I've got cosine is negative. So I have to ask myself, where is cos negative? Well, the CAST rule, positive there, which means cos is negative over here and over here. So I'm going to get two answers. One that just goes over into the second quadrant, and then one that continues on to the third quadrant. I go to my calculator, and my calculator is successful and tell me the answer is 135. That's great news. So that means this is 135. Figuring out what the actual answer is for the second one requires some puzzling. One way you might look at it and say, well, if it goes, that's 135. If I go backwards, that would be negative 135. And I could do 360 minus 135 and get 225. So that's one possible answer. Or way, that we get the answer. I know it's the correct answer. The other way you can look at it is this. Here to here is 135. So this little related acute angle must be 180 minus 135. So that's just going to be 45. So if that's 45, then this must be 45. And so now that rotation goes 180 plus 45 to get to that second spot. And that's going to be 225 as well, which is the same as what we got here. So it just requires a little bit of puzzling to figure out that second rotation, this second green one that goes from here all the way around to here. And either way you think about it is going to be correct. And finally, the last one. Oops. Just make myself some space here. So, again, I've got to use the CAST rule, C-A-S-T. I have to figure out where is cos negative, because it asks for a negative ratio. So all of them are positive up there, and this one's positive. So this is negative, that's where tan's negative, and this is negative. So it's going to go here and all the way around there. Now, when I put this in my calculator tells me negative 60, I think. Which is kind of weird, because that's actually not any of my answers. Except it kind of is. Our calculator tells us negative 60, that's down here. But that is not an angle in standard position. And I've asked for all the positive rotations. I've only looked for the positive rotations. So, although it is correct, it's not within the domain that I asked for. And it's your calculator trying its best to give you a clue. And it's just saying, hey, look, I can't find those angles of your two green ones, but I can tell you it's the same as negative 60. Well, that makes my math okay, because if that's a 60, this is a 60. Which means my first answer of this guy right here is going to be 180 minus 60, which is 120. The second answer, which I'll do orange again, is going from here all the way to here. And the calculator said, hey, that's negative 60, which means I have a full rotation, but I got to take away the 60. And that means I have 300 left. So the other answer is and 320 degrees. And so this is a great example of why we're drawing these pictures, because our calculator, although it's great and handy, it's not going to understand which angles I'm talking about. So it tries to give you as much information as it can, but it doesn't know where you're looking, because there's so many answers. And so it defaults to some simplest one. And in this case, negative 60 isn't really the answers I'm looking for, so you have to use your diagram to get the other sides. So I think that's it. If you wanted to try some more practice questions, you can go to page 338 and find some there. But really, I think the review questions we've done in this package are most valuable, and so you can go back and try any of these. And although this video started here, remember that we do have answers for the whole review on Google Classroom. All right. Good luck.